Welcome everyone. I am Brij Mohan from the Department of Mathematics, Hansraj College, University of Delhi. Today we are going to learn Mathematica, and we are going to learn it in the lecture series form, and in which I will present 5 lectures. And the very first lecture today we are going to discuss here is Basics of Mathematica and Built-in Functions. So let's start. Let me first make it clear that what is Mathematica is all about, and how we are going to use it, and what are the benefits to use the Mathematica software. So Mathematica is a symbolic mathematical computational software. So you can see here the word symbolic. Symbolic means we can understand it by using one example. For example, you are using the C++ code or any other programming language code. So you need to use so many lines to adding two numbers. Let's say you want to add two numbers, a is equal to 5 and b is equal to 10, then your answer should be 15. But to do this work, you have to write all the necessary code which will work together to create an output for you. But in Mathematica, there is no need to do such work, and you can directly assign the variable value for a, that is a is equal to 5, for b, that is b is equal to 10, and the total value a plus b will be your output as 15. So that there is a big difference between the programming languages and such software, and these software are known as the Computer Algebra System software, and in short we can call it as the CES software. So Computer Algebra System software work on symbols. That means every variable whatever you are taking, the software take it as just a symbol, and you will put the value on that symbol, and you can directly work on that particular code whatever you are writing in the Mathematica software. And this Mathematica software is not only reserved to the mathematics, it is also in very research or engineering, mathematical and computing fields we are using. So the next thing is, whenever you are using Mathematica software, you need to understand the concept that how we are using that particular software. So there is a Wolfram engine. Wolfram is the company which provides you the Mathematica software, and engine means that whatever you are doing in front of you, that means whenever you are using some system, so you are working on editor rather than their engines. So engine is in the background that provides you all the necessary computational work for you, and you write on editor and you see input or output on your editor. So engine is the base, and this is known as the heart of the all products. Whatever products Mathematica company that is named as Wolfram is making, so Wolfram engine is the base of all the products whatever they are using. So they use Wolfram language to writing the Mathematica code with all its computational intelligence, algorithms, knowledge base, and so on. And you can use the desktop product which are Mathematica, and some online product also there, Wolfram Alpha and other products what you can use directly online. The next thing is Wolfram Player, or secondary we call it as Cdf Player. CDF stands for Computable Document Format, and in short we can call it as CDF. And you know already that PDF is is in a static format in which you work in your document, and you create your document file by creating save as PDF. So PDF is portable document format, but in PDF you can't use the dynamic things. That means if you want to see the animation, that will not work in your PDF. So for that purpose, Wolfram Player is established, and you can use that in dynamic format, CDF. So CDF makes easy to author interaction, empowering readers to drive content and generate results in live. So there are many ways to access the Wolfram Mathematica, and the first one is you can use in offline mode. In offline, what you can do, you can download first the Wolfram engine, which is basically the command line execution format. So you can use with one editor, and the name is Wolfram script. So script provide you as an editor environment, but that will be in the command line format. Or you can use Mathematica software, which is a paid version, whereas engine is free. So you can download it freely from the Wolfram site, and you can use with the script. Other options are there. You can use Mathematica Online, and that is site is wolframcloud.com, in which you will be provided some basic plan in which they will give you some MB space, maybe 25 or 50 MB space, and then you can work on your file there on online. But if you want to go beyond the limited space, then you need to purchase. Another one is Wolfram Alpha. Wolfram Alpha is basically free form inputs platform in which you can directly write in your English language. For example, you want to plot the sin x from some limit to limit. So you just need to write it, plot sin of x from something to something. So for example, minus pi to pi. So I will just write plot sin x from minus pi to pi. It will automatically convert your language to the mathematical language, and it will show you the output. So that is the good thing about Wolfram Alpha. You need to go to that. So here is the basic environment. Whenever we will go to the Mathematica software, you will open in your desktop. So this is the version for paid version, and paid version will be look like in a GUI way, that is graphical user interface. And you will see here, you will get one white window here, which is basically your notebook or command window. And here is the menu bar in which you can go to the different menu, whatever given there. And you can use the drop down menu to search more options. And if you will minimize some files, the other open file will be here in the left corner. And in the right side, you can see the zooming, that here we have, for example, 100% here, and you can make it magnify, so you can easily work and easily understand that code. Mathematica just not provide you the programming environment, it also provides you the palettes. Palettes are basically the structures in which you can write your work directly as in your notebook. For example, you want to write summation I is equal to 0 to 10 and the I square. So you can directly write in this way also. There is no need to work like a programming structure, that how I will write, like because I am using sum here, then I will go to some sum, then some code, then some range, and like that. So this is the mathematical coding way, and the palettes provide you environment, so you can directly write summation as what it is. So there are different palettes are there, and basic math assistant is there, classroom assistant is there, and one writing assistant there. So in which you can see the basic palettes. For example, for writing here your root of something, you will just click on that one and you will get the root, and you can write any value in your black dot here. Similarly, you can understand the writing tool, whatever background color you want to use, what text color you want to use for some writing or formatting, you can use that one. So in Classroom Assistant, you will get all basic math assistant tools and some writing tools also. So Classroom Assistant is one in which you can use all type of palettes and some other also. So here are some palettes example. In the first, we can see that the basic math assistant provide you the structures. So you can just click on that particular palettes and you can directly write a to the power b. A to the power b, you will get directly the value for that notation, that means superscript notation, or you want to write some integral value, you can write also that one. So all these structures are available in palettes, so you can directly work on that, and there is no need to go to the coding if you don't want to work on coding purpose, but you want to learn your Mathematica and to do your mathematical work. Some writing assistants are there. So here you can see there is a title cell, then this one is the subtitle cell, and other text are there, and item cell and text cell. You can create all this type of work in your palettes. Classroom Assistant provides you all the assistant whatever in basic and writing. So here are some simple calculation what you can do in Mathematica. To do your input output work, you need to first understand that for execution you need to enter with shift. So in your keyboard you will just press shift first, then will and hit enter key, then you will get your execution work. And for new line there is a normal enter. So whenever you will enter in your editor, that was the white window in the starting, and you will get the new line. But if you want to go to the execution, then you need to shift plus enter. So remember that is the very important part. So now here are the inputs. Each line you can execute separately and you will get the output. So whenever you will write 2 plus 2, you will get the value 4. So simple calculation are there that you can directly use. That means you can use Mathematica as a calculator. Then you can write like this one. As in calculator you see we use for power cap. So you can use 5 cap 3 plus 4 star for multiplication, minus 1 by that means forward slash for divide. So you can use all the calculator symbols in your Mathematica. So that means you can directly use Mathematica as a calculator. Then there is a one input n square bracket and percentile. That n stand for that your numerical value. For example, you have previous output here and the output is 273 by 2, but your answer is not in the floating point values. That means not in real number, that is in a rational form. So you can use the percentile for your previous output and you will put n outside. That percentile should be in square bracket, then you will get 136.5. that is the decimal value. So n is stand for numerical solution or numerical value, and percentile is for previous output. Similarly, other input is this one, x is equal to 3. That means we are assigning some value 3 to x, then x to the power 4 plus x you can execute, and your output will be 84. Another input is over here, r is equal to 2, and the 2 into pi into r, and you can see here that pi is written as capital P and I. So we will learn about how we will use the mathematical notations that will come. So here is an example for simple calculation. For each input you just write to just input and the shift enter, then you will get your output. So let us understand the basic rules of Mathematica, how we will use that, and what are the some set of rules what you need to follow. So Mathematica has symbols, as I have already said. The Mathematica works on symbols, not in variables, but we call it them variables, as we already habitual to that. That's why we do that. So every symbol starts with capital letter. That is the first thing. So you can see here, for writing pi, p should be capital; for writing sine, s should be capital; for writing log, l should be capital, and so on. Whatever word you are using as a function, but as a symbol, right? Symbol is the correct word, function is not a correct word, but we are habitual to that, to calling as function. So that's why you can use to understand the Mathematica. Okay, the second rule, that was the first rule. Second rule is, if symbols contains many words, then first letter for each word should be capital. So let's say the one function is find root. So find root are the two words, find and root. So f should be capital, r should be capital. In the same manner, linear programming, so l is capital and p is capital. If you want to write plot 3D, then p is capital, d is capital, and so on. Numerical solve, so n is capital, s is capital. So whenever you are using the bunch of words in your function, then each and every word should start with the capital letter. That is the second rule, right? And the third rule is, if symbol takes inputs, then the pass is square bracket. So whenever you are using function or some other things that are taking the arguments, so you need to write like this one: sine square bracket, log square bracket, plot square bracket. In these square brackets you will give the values for that particular symbol or function. Fourth is, values are separated by comma in list, array or range. So whatever you are using, a list you are using, or some array, some matrices, some range, then all the values should be separated by commas. So that is, for example, you want to write 2, 3, 5. So 2, 3, 5, like this one. And the fifth rule is, curly brackets is used for list, array, range, like this one. So here is, this one is range, because we are defining first x here, then the starting value and the ending value. So that is x from 1 to 10. So that means it is taking x as a range. Here you can see this is the normal list, or we can call it as 1D list, 1, 3, 7. That is the one dimensional, and 3 points are there, 3 values are there, 1, 3 and 7. Another is two-dimensional list, which is also known as the matrix, right? So you need to write first list first, then comma, second list second, and then you will put another curly bracket to make your 2D list. So these were the basic rules you need to follow, and if you understand the basic rules correctly, then you will do your work efficiently. The most important part to understand any function is syntax. Syntax is basically the format, how we are using any function in Mathematica. I am taking one example here to make it clear to you that, let's say, example is find root. So find root is a function. You can go to the help to find your function, to see the syntax for that, or in your command line you can just write question mark find root. So you just put the function name or symbol name, and before that you just put one question mark. So for any function you just put question mark, and for example I want to search for plot, then I will do that one, question mark plot, and shift enter. I will get easily the help menu. So you will get directly the help menu for that particular function. So here is one example, find root. Now you can see that there are 4 syntaxes. So first syntax is find root in square bracket, that means we are using some input to that particular function, and f is the function, and this one is some type of range you can understand, or some input for some values here. So searches for a numerical root for f starting from the point x is equal to x naught. So that is the starting value. Whatever for function we will search one root, and you will get easily the value for that particular function whatever you are using here. So like this one we can understand how the function will work, and what is suitable for us to make a function works. Let's say second syntax here, find root LHS equal to. Now you can see here equal to is basically 2 times equal, not 1 time. Equal to is this one. So basically this is equal to. So left hand side equal to right hand side. For example, you want to write some equations, so in that case you need to write in this way. Then you can write your point value x is equal to x naught, then you will get your values easily. Similarly for other syntaxes, for example you have multiple functions, then you will put all in commas and then curly bracket. The same rule we will apply for separated in comma and put in a curly bracket, and values, initial values for each functions, that syntax will work. And same in the equation for case. So that is the way how we can understand any function in Mathematica. So that is the necessary part, that before going to use any function you need to understand the syntax and what is suitable for you. So there are different kind of operators in any programming languages. The same here in Mathematica, we can see the basic mathematical operator, addition, multiplication, subtraction, any other. And relational operator also there. Relational means you want to compare two values to each other, then you will use the relational operator, less than, greater than, less than equal to, greater than equal to, or equal to, and that is stand for not equal to. Other operators are assignment operators, that is whenever you want to assign some value to some variable, basically we call it as symbol here, but you can take variable to make it clear to you, and that is for one time equal, that is assignment operator. Another is set delayed operator, that is also one kind of assignment operator, but the difference is whenever you will put assignment operator, the execution will work at the same time, but whenever you are using set delayed, that means you are delaying the execution, then in that case you will write colon equal. So that is colon equal, and this particular operator is known as set delayed operator. Another are logical operators. You can use AND operator, 2 times address of operator, that is OR operator, then NOT operator, then XOR operator. And XOR operator is not like all other operators, it is like a function or like a symbol. So you can use that also. So here are some examples for your operators. So as we have already seen some work, as in whenever we were talking about the simple calculation in mathematics, the same way you can do that. You will put some input like this one, and you will put some shift enter, you will get output like this one. Then for numerical output you will just put n, and the percentile is for your previous output, and you will get the value 136.5. Another input is 3 is greater than equal to 10. So we are using here the relational operator, that means 3 is greater than 10, yes or no, that will come to your output. So 3 is not equal to 10, the value will be false. X is assigning 7 and x is equal to 7. Equal to means relational operator is there, so it will check x is equal to 7 or not. In that case your value will be true, as in the previous line we have x assigning 7. Another input, x set delayed 3 and x to the power 4 plus x, then you will get value as 84. Here I am not using any semicolon after the line. So basically semicolon is for not showing you the output. So if you want using some input in your Mathematica and you want to show, you don't want to show your output, then you can use semicolon. So I will write, for example, plot something and semicolon is there, then output will not occur in your editor. But if you will remove this semicolon, the output will be there. So without semicolon also there is no output. So that means execution is not working here because we are using set delayed operator. Another input, you can see that logical operator is there, and so 3 is less than 5, yes, it is true. 5 is less than 3, no, it is false. So true and false will be false and the output will be like false. And other, similarly you can understand the given input and output. So let's come to built-in functions or symbols in Mathematica. And there are so many, thousands and thousands functions are there, and each and every year many functions are coming and they are adding different type of functions whatever is required in different stream of educations or engineering or sciences. So here are mathematical function. I categorize personally some function in some categories so that I can easily make it clear to you that how you can understand the mathematical functions. So in the first we can see that we have trigonometric functions here, sin x, cos x, tan x and others. Similarly we can use arc sine. Basically arc sine is stand for inverse functions. So if you want to write sine inverse, cos inverse, tan inverse like that, then you need to use arc sine, arc cos, arc tan and so on. There are exponential function, that is exp, logarithmic function log tan, that means log function with base tan, that is the meaning for log tan. And some abs for absolute value. If you want to find out the absolute value for some functions or some value, then you will use that abs. And you can see here the Mathematica rule are there, that means every word has first letter as capital and input will be in square brackets, whatever we will see in the coming examples. So different functions are there, square root, sqrt for rounding the value, for mod, that means you want to find the remainder, then you will need to do mod functions. Then maxima minima, that means maximum value for and minimum value. Then you can find out also GCD and LCM, least common multiple or greatest common divisor, and random real, factor in integer, prime, next prime, random prime, and divisors and power. So there are some mathematical function what I have collected here to make clear to you or make easy to understand that what mathematical functions we are using in Mathematica. Some others are also there, but that is sufficient to understand. So here are examples for all these functions and we can understand easily. So if you want to write sine 30, that means sine 30 means that is radian value, not in degree. So remember that whenever you will write in Mathematica sine 30, that means 30 will be picked as input like a radian value. So sine 30 output will be there, but for finding the numerical value n function is used outside the sine 30, then you will get the minus 0.988032. Another is if you want to find out the sine 30 degree, then you need to write degree word here, and you can see again Mathematica rule is applied, d is capital. So sine 30, that is 1/2. Similarly, if you want to find out the sine inverse 1, then arc sine 1, and then you will get the value pi/2. So all are these are inputs, each and every one you can write in your Mathematica each line and just shift enter and you will get your output. Exp, that means exponential, 3, that means e to the power 3 here. Another is log 10, so that means you are finding the value for 10 as your log value, then you can put the n outside, then log 10, the value will be 2.30259. You can find out the absolute value for minus 7, that will be the positive value 7. Square root for 144, that is 12. So output will be 12 here. You want to find out the remainder for, if you divide 5 by 3, then the remainder will be 2. So your answer should be 2. So you will put mod function there, mod 5 3, and then output will be 2. Then you can find out the minimum value for a list. List means we are putting some values separated by commas. That means 12, 34, 48, 92, and the minimum value is 12. Then the answer will be 12. If you want to find out the maximum value, then you need to just put your list inside your max function, that 2, 4, 7, 8, 2, 3, 6, 7, like this one, and you will get your value 78. Other functions are similarly you can do, and if you want to find out the GCD, they just put GCD there and some values inside the GCD function. For example, 25, 10, 15, and the GCD will be 5. You can find out the LCM. Similarly, you can find out the random real. Random real is basically to find a real value randomly, and there is no need to any input in your square bracket. So you need to just put it as blank, random real, and any real number in between 0 to 1 will occur. Any number, it may be 0.333, something like this one, or anything, whatever the system will pick for you. You can use function factor integer. So you will put some integer value here, and you will get all the factors whatever this particular integer has. So that is 2 to the power 1 into 7 to the power 1 into 67 power 1. So you can understand the output also, how the output is shown to you. 2 comma 1 means 2 to the power. So first is the value and this is the exponent. So 17, if it is, for example, let's say 3 comma 2, so that means 3 to the power 2 will be your factor. You can find out the prime. Prime 5 means your fifth number, fifth prime 5. So it will get the nth. So it is basically the n value, nth prime. So you will get the 11. So prime is 2, 3 like this one, and the fifth one is 11. You can find out the next prime for any value. For example, you are picking the value 20 and you want to find out the next prime, then the next prime is 23. Then the random prime is also there. You want to pick the random prime between some values, for example 10 to 20. There are 11, then 13, then 17, then 19, 4 primes. But if you are using random prime, that means any in between from 10 to 20, that is basically from all 4. So anyone will be picked here, and this will be your output. Then the divisor function is there. So you want to find the divisors, the total number of divisors, and the total values will be as your output. Then you can use the power function, 3 to the power 2. You can write the value as 9 as your output. So some other built-in functions are Boolean output functions, and Boolean output functions means whenever you are using some functions, then your output will be in Boolean way, that means true or false. So number q means whenever you will see the q word is there in mostly I can say in 90% functions, whenever you are using some q there, so that means it will be easy to understand that will give you some Boolean output. So it will check basically. So number q means is the input is number or not, that will tell you. Integer q means if input is something is there, then it will check if it is integer or not. Prime q, is it prime or not. Co-prime q, is it co-prime or not, like this one. Even q, odd q, and divisible also, if it is number is divisible or not, that will also check. But you can see that here there is no q, so there are exceptional functions or symbols there that you need to understand. Let's go to the example for that. So number q, I am picking the value here. number q 1 2 3, is this number or not? Yes, it is a number, so that's why the output is true. Integer q, is it an integer 3.5? No, because it is a floating point value, and that's why the answer is false. Then the prime q, is this number is prime 37? Yes, is the prime, so answer will be true, otherwise no, false. Co-prime q, all the numbers given in the function input, that is 10 or 13, are the co-primes to each other. Co-prime means GCD should be 1. If the GCD is 1, then the number is co-prime. Yes, GCD is 1, that's why output should be true. So you just need to just make it clear that you can use directly all built-in functions to make your output visible easily to you, and you can use your output in your coding or programming, on your research, whatever you are in. Even q also, even or odd and divisible. Is this number 8976 is divisible by 3 or not? So you just put to number first here, and then the value by which you want to check the divisibility. So that is the true. That means 3 will divide this number and you will get your output. Another built-in functions are numerical computation functions. Numerical computation functions means that you need to work for finding them your minimize value, your maximum value, finding minimum, finding maximum, nearest, and some find root, linear programming. Basically in mathematics you use all these type of functions or functionality to get your answer in your calculus or real analysis or linear programming also there. So you can directly use all these functions to make your output efficient. And some examples for that are here, and you can easily understand that. Let's say first input is minimize this function. Function is 2x to the power 2 minus 3x plus 5, and for what you want to minimize that function, you will put that variable here, x. Then your output will be like this one, 31 by 8. That means 31 by 8 your minimize value, and for what you have minimum value, that is x is equal to 3 by 4. So that is called as rule. This is called as rule. Whenever you will see like writing this one, that is called as rule. The name is rule, and that is also very important whenever you are going to research or in your coding. So that rule will be used. So remember that also. So next is maximize. This is the function, then x, you will get the maximum value, and the maximum point is x is equal to minus 3 by 4. Similarly, you can use the nearest. Nearest means you want to check this list and you want to check which point is near to the 15. So for 15, I think this is the 16, and the 16 is your answer. Similarly, you can see the n sum. N sum is the numerical sum. Here is the function 1 by I square, and for I is equal to 100 to 10 to the power 6, it will put all the values there and it will make output for you. So it is 0.0100492, that will be your output. Another function is find root. As I have already discussed that find root, that your function should be there and the starting value for what value you want to start. Basically this function is work on Newton's method, and that Newton's method is come from numerical methods or numerical analysis. You can go to understand, if you want to understand the functionality of that particular function, that is from numerical analysis, and this find root function use the methodology Newton's method. Another is linear programming. That is linear programming, that means you need to put in the matrix form. Here is value 1 and 2, that is in first 1D, and that is 3 4, that is 2D, and some another values, that is 5. First let us understand, to understand this linear programming, let us understand this one, because both are the same. Let's say we want to minimize the function x plus 2y, and the equation is 3x plus 4y greater than or equal to 5. So that is our one equation, and x should be greater than or equal to 0 and y should be greater than or equal to 0. That means x and y are positive values, and you want to put the solution for x and y, and you will get your answer as 5/3, that is the minimum value for the point x is equal to 5/3 and y is equal to 0. And the similar, now you can understand the above, that is your function 1 and 2, that is 1 2 matrix is for function, then 3 4, that is your matrix for all the equations, because here is only one equation, that's why I am writing here 3 4, and the greater than equal to 5, that is ax is equal to b. So basically this one is b and this is your a. You can understand now easily. And this is your function, whatever equation is there, function, so that is 1x plus 2y, so 1 and 2 is here, then you can work on that. That's how it works. Another built-in functions are let's say sum function, that you want to sum for some value, you want to product or some sort, some mean, median, commonest, basically is for mod. In statics you use mod function, and the name for that in Mathematica is commonest. And the variance, the covariance, the correlation, all these are, I think, from the statistical background, so you can easily understand that. And there are some other functions also, whatever you will learn in the coming slides or coming lectures. So be connected to that, because we are going to follow the lecture series, and that is only first lecture. Then we will go to the second lecture, in which we will learn plotting and graphing, and in other we will learn the programming in Mathematica, how we will do the programming. So there are many lectures, so I will record for you 5 lectures, and that is the first one. So be clear about it, that all these functions whatever we are using here, there are only some functions, other functions also there, we will learn one by one. Okay, now here is an example. So here you can understand the sum function. So you can use sum, S should be our capital, as I already said that the rule should be applied, as capital, the name sum, then square bracket for your input, curly bracket for your range, I from 1 to 10, and the function I square is there. So you are using basically this one, sum I square, I is equal to 1 to 10. If you want to write this one, you can use palettes also, I have already discussed in the starting, and you can use sum like this one, that is the Mathematica command to doing the same work, then your output will be 385. And you can use the product also, that is product is nothing but this one, I is equal to 1 to 5 I cube, and your output will be like this one. You can sort also, sort means you can arrange in ascending or descending order. So without any option, you are just putting one list inside the sort function, and the answer is 4 12 16 34. That means you are arranging this in ascending order. Another is sort, but you are putting some option name here, and that is greater, and the G is capital in that word, the same rule, and you will get 34 16 12 and 4. That means you are arranging this list in your decreasing order. Another function is mean. So if you want to find out the mean function, so here is the values 2 4 6 8 10, and the mean value is here 6. Another function you can use median. Even if you want to find the median for the values, then you can easily find that. Then the commonest, basically that is mod, as I have already said, and the answer is 2. Similarly, we can find the variance also. For example, you have some list, different values are there, and if you want to find out the variation, then your answer will be directly to you. So now you can easily understand that how we can use all the built-in function in Mathematica to make very easy our work, and we can understand the working in Mathematica is also easy because it just follows some set of rules. So see you in the next lecture. Thank you. Be connected.